Hi everyone and welcome back to our YouTube channel. In this lecture, I will show you how to use the Sarrus rule to compute the determinant of a given square matrix. And here's the Sarrus rule and the way we use it. Okay, first of all, in order to implement this rule, we should be given a square matrix of size 3 by 3. So in the case of a 3 by 3 matrix, we are able to use the Sarrus rule. Okay, now let A be the given matrix in this form. We have a 3 by 3 matrix here, and let's try to find its determinant by using the Sarrus rule. Well, up to this point, actually, we can find the determinant of this matrix using both the definition of the determinant, using the permutations. As we all know, we find the permutations and their signs, and then compute the multiplications with respect to both permutations and the entries of the matrix. This is one way to compute this determinant. And another way to solve this problem is we can use elementary row operations. What I need to do is just eliminate this matrix into row echelon form and find the determinant, right? And we just keep track of the type of elementary row operations, and based upon the number of these three different types of operations, we compute the determinant accordingly. And this is another way around solving this problem. In other words, computing the determinant. And Sarrus rule is a better and much more easier and convenient way to compute the determinant of a matrix in the case of a 3 by 3 matrix. Okay, and then let's proceed to the solution and how we can apply this technique. Okay, here's the way. There are two possible ways. The first way is, first of all, write all the rows as they are, and as you see, 1 3 2 2 1 and 0 1 3. These are the three rows, right? And then expand the top two rows below the last row. What I mean is, we rewrite the first two rows below the last row, which are 1 3 2, which is the first row, and 2 0 1, and which is the second row. And then we apply a kind of multiplication and summation strategy. We multiply the elements in this direction, as you see. So 1 times 0 times 3 is equal to 0. So write it here, and then continue to our multiplication. And again, in the same direction, here 2 times 1 times 2, and it is equal to 4. And 0 times 3 times 1, and this is equal to 0. So sum these values up. We have 0 plus 4 plus 0, and it is equal to 4. And this is the plus part of the summation. So this is the first part. And the second part comes from the other way around it. So now let's do the same thing in the reverse direction. So 2 times 0 times 0. I started at the top right corner and move to the left bottom corner. So it is equal to 0. And then 1 times here in this direction, 1 times 1, and this is equal to 1. And then 3 times 2, that's equal to 18. And sum these values up, and we have 19, right? 0 plus 1 plus 18 is equal to 19. And this is the minus part. Put a minus sign here, and the result is 4 minus 19, and which is equal to minus 15. And here's the determinant. It is as simple as that. So we just expand the first, in other words, top two rows below the last row, and apply a multiplication and summation strategy as I have shown you. Alright, and another way to solve this problem is we can find the same result by applying another strategy like this. Again, now I write the rows as they are: 1, 3, 2, 2, 0, 1, and 0, 1, 3. And this time I do not expand the rows, but I will expand the columns, the first two columns. In other words, I take the first column and I take the second column, alright, and then I expand this matrix to the right, So here is the first column. I first the first column, 1, 2, 0, to the right of the last column. You see, 2, 1, 3 is the last column that corresponds to the matrix A given in this example, and I expand the left two columns, in other words, the first two columns on the left to the right of the matrix. So, and one more, I put 3, 0, 1 right over here, and again I apply a multiplication and summation strategy here in this time. Okay, 1 times 0 times 3 is equal to 0, and 3 times 1 times 0 is equal to 0 again, and 2 times 2 times 1 is equal to 4. And in the other direction, now let's move from this direction, as you see. Okay, so 3 times 2 times 3 is 18, and 1 times 1 times 1 is equal to 1, and 2 times 0 times 0 is equal to 0. If we have only one 0 in a multiplication, then the result is equal to 0, you know. And again, sum these values up. 4, 0, 0, it's equal to 4. This is the plus part, this is the positive part. And sum this value up again. 1 plus 18 plus 0, this is equal to 19. This is the minus part, so this is minus 19. And our result is 4 minus 19, which is equal to minus 50. And as you notice, we found the same value, right? So in Sarrus rule, we can expand our matrix either by using the top two rows or by using the leftmost two columns and expanding this to the right, or in the case of rows, to the bottom of the last row. And the result would be the same. And it is a very simple implementation in order to find the determinant of a given 3 by 3 matrix. And I hope you enjoyed this method as well, guys. So in the next lecture I will show you another method to compute the determinant of a given square matrix, which is called the Laplace or cofactor expansion method. And up to that lecture, have fun and see you in the next lecture.